Next, we look into elementary data link layer protocols. In the earlier video, I have shown you what are the data structures and the library procedures which are defined in protocol.h file, which will be used by these data link layer protocols. So in respect of the data structures and also the library procedures, now we are ready to start our discussion with elementary basic data link layer protocols. So let me tell you the classification. Data link layer protocols are generally of two types. One is elementary and the other is more complex. The fundamental characterization of elementary protocols is that they are simplex, and these are duplex. Okay, simplex. Duplex, I mean full duplex. Like what I mean, let me explain to you. There are three protocols here. The one which I have highlighted here, 1, 2, 3. Look at that, simplex, simplex, simplex. Simplex means the communication will be only from one to the other machine. Host 1, host 2, connected by means of some communication media. Okay, is a medium. So host 1 would like to send data to host 2. Host 2 will not send any data to host 1. This is called simplex, one way. So simplex means one-way communication. Here I can have two-way, either one at a time or both at a time. Two-way can again of two types, one at a time. Host 1 may send host 2, host 2 will wait, and then host 2 will send to host 1, one way at a time, or maybe two way at a time, full duplex. So either way. And within this domain, we have again a set of three protocols. Let me write what are they so that you can have the taxonomy at one place. The first one is called 1-bit sliding window protocol. Okay, second, select, you can say go back in. And third, selective repeat. These are all classified as a second set of complex protocols or full duplex protocols under the banner called sliding window. So essentially, the complex protocols which I say are nothing but sliding window protocols. So elementary data link layer protocols are simplex protocols, and sliding window protocols are bidirectional data transfer protocol, that is duplex protocols, not simplex. This is the classification, the hierarchy. So first in this video, we will start with the first set of three protocols, talking about an unrestricted simplex protocol, simplex stop and wait protocol, simplex stop and wait protocol for a noisy channel. Now, recollecting in the last class discussion that we made some certain assumptions. What are the assumptions? Machine A want to send data to machine B. This was the first assumption. Machine A want to send data to machine B. This is the meaning of simplex. We assume A has infinite amount of data. So that the machine A doesn't have to wait at any time for data. Infinite data availability. Okay. Machines never crash. Machines never crash. And data link layer will accept a packet. Data link layer accepts packets from network layer and encapsulate it within frame. So we formulate a frame, we make a frame at data link layer by adding header and trailer, that is a checksum. And we said then it will transmit and machine B will receive. So these are the assumptions. In respect of that, let us now try to first take up the first data link layer protocol, elementary data link layer protocol by name Simplex Utopian, The first one is called Simplex Utopian Protocol or Simplex Unrestricted Protocol. So what is that? Let us try to understand. Okay, so let me, this pen is getting deselected. Just hold for a moment. All right, now it has come. So unrestricted simplex protocol, or also called Utopian. So let us take up that discussion first. Okay, let us take up that discussion. Okay, there is some delay actually for which it is getting stuck. So what are we saying? We are saying first protocol as unrestricted simplex protocol. This is also in short known as Utopian protocol. Utopian, what is the word utopia mean? Utopia means a place which has unrestricted conditions, place where you have ideal conditions, an ideal place where nothing goes wrong. That is called utopia. Place with perfect conditions is utopia. So here we assume for the protocol we have perfect conditions. But let me write what are the essential characteristics of Utopian protocol. One by one I will write. It is first of all unrealistic. It is an unrealistic protocol. Means the assumption that we are making does not actually exist in practicality. That's why we just say unrealistic. Why? Because here we assume nothing goes wrong. Nothing goes wrong. No errors. That is perfect ideal conditions. Conditions are ideal. Means the machine will never go wrong, machine will never crash, the channel is error free, noise free. Okay, that is the meaning of unrealistic conditions, perfect conditions. And because it is simplex, it means data is transmitted in only one direction. Simplex. Okay, means whatever data is sent by the sender will be definitely received by the receiver without any loss. And whatever rate the data is sent, that is another important point. Whatever rate at which the sender sends the data, the receiver will have sufficient capacity to accept it. So therefore we say infinite buffer space is available. Infinite buffer space is available at the receiver. The processing time is ignored, otherwise loss of packets will happen. Time for processing the packet after receiving by the receiver is ignorable, negligible. And the channel, the media, we say the media or the channel never loses or damages the frames. So are you not able to observe from these facts that it is unrealistic? That's why we say unrestricted, no restriction. Whatever sender want can send. Whatever receiver will get will receive it, process it in no time. So we have infinite amount of buffer space available. Infinite buffer space available. Okay, and nothing goes wrong. That's why unreality. Media will never lose out, never loses or damages the frames. Unreality. So what I do is the working of that I will show you in the form of procedures which you have to also implement like a program using C or C++. So all these three protocols I would appreciate if you implement it in the program and simulate the behavior. So let's go to the slides, PPT, and then we try to study the working principle of Unrestricted Simplex protocol. This is the first one. Again, I'm trying to highlight the important points. Just pay attention. First, simple unrealistic protocol. Data is transmitted in only one direction. I already told you. The transmitting and receiving host are always ready. That means if you remember, I said earlier, again I'm saying, this is host 1. I'm calling it as transmitter TX. Host 2. This I'm calling it as receiver RX, connected by means of some communication channel. Okay. Processing time of transmitting and receiving is ignored. Infinite buffer space is available. I already wrote those points. No errors occur, that is no damage to frames or no lost frames. Perfect conditions. That's why we named this protocol as what? We named it as Utopia. We named this as Utopia, or you say Utopian Protocol. Utopian Protocol. So look at that. That's a simple code to demonstrate how it works. This is the simulating code for sender. It runs infinitely. Infinite running. Infinite loop. So I'm assuming the existence of a procedure called from host. Look at this. The library procedure. So it takes data from host, this protocol, where in a buffer. Buffer means some array, something like that. And then this is nothing but the packet coming from the host on network layer. So this packet is encapsulated in s.info. What is s? S is a variable that indicates the frame. So buffer is encapsulated in the information field of this, and then it will send the frame. So from host means it will take the packet from network layer, send the frame means it will send it to physical layer. Because this is data link layer. Has a meaning. It is taking data from network layer packet, putting the packet into the frame S and sending the frame physical layer. So it will arrive at the receiver. So what is the receiver doing? Wait for the event. Wait is another library procedure. Event is maybe a timer, or event can be arrival of frame, something like that. So when the frame arrives, it will get the frame. Look at this. It's slightly indented. Indentation is lost. So get the frame from where? From physical layer. And then because it assumes the packet is error free, so it will directly transmit it to network layer. Right? What? R.info. I'm saying the frame name is R now. It was transmitted as S. Here it is called as R. So R.info, which is nothing but the packet, is transmitted back or sent back to the network layer. So that's how the communication takes place. Now the more detail with the algorithms and with the detailed procedures, I will try to show it in the next slide. You can check. Look at this. All right. So let us read the protocols with more finer details of the library procedures. Provides for data transmission in one direction from sender to receiver. The communication channel is assumed to be error free, and the receiver is assumed to be able to process all the input indefinitely or infinitely quickly. No delay. Consequently, the sender just sits in a loop pumping data out onto the line as fast as it can. So What are we first saying? Event type, look at this. Event type can be a frame arrival here, only one. And the protocol.h, which contains all the library procedures that we have seen in the earlier class, are put here. And this is a code of sender of 1. 1 means the first protocol, protocol 1, Utopia. So we are defining a variable by name s of type frame. We are defining a variable called buffer of type packet. So packet will come from network layer. Frame will be formulated at link layer and forwarded to physical layer. Infinite loop. From network layer, take the packet in buffer. Put the buffer in the frame as .f, as .info, and to physical layer ampersand s. Comments are also very clearly shown. Buffer for an outbound frame, outbound packet. Go get something to send. Copy it into the frame, send it on its way, and it keeps on working like this, keeps on looping like this. So again, go back and take another packet. So infinite amount of data is available, so it keeps on taking the data and keeping on sending it to the network layer, to the link layer, and then keep on sending and continuing. That's why it is called Utopia. We assume infinite space is available and sender can send the data at any rate. What is happening at the other side? At the other side, you can see the receiver. Event type, event could be frame arrival. The while of true. It wait for the event. Event is nothing but the arrival of the frame. Wait for the event to happen. Wait for the frame to come. So whenever the frame comes from physical layer, it will accept it in the variable by name R. And it is supposed to forward that to the network layer. So to network layer ampersand r.info. Again it goes back. Again it waits for the arrival of the frame. So continue like that. So it's a very, very simple protocol. So I want you to write a simple simulating program for this. All right. And try to exhibit or show the procedures. How this from network layer to physical layer, these procedures we can assume and implement and try to formulate the first protocol. Okay. So this is the first protocol. Never go wrong. It never go wrong. Now there are certain delays that you need to understand in respect of that I will explain to you. What are some of the delays which are defined in here? Time delays. Suppose this is host 1. This is the transmission media or the communication channel or wire or whatever. This is host 2. Suppose if it want to send some frame here, this is a frame that it want to send over this communication channel. This channel will have its own bandwidth. We described this earlier. The bandwidth is defined in terms of BPS or bytes per second. I've already explained to you the distinction between these two. These bits, these bytes. The rate at which it can carry the data, the rate at which you can send the data onto this channel. Okay, like for example, if my bandwidth is 3000 bits per second. If my frame is 1000 bits, meaning what? Meaning this particular machine this channel is capable to accept or send 3000 bits in 1 second. So 1000 bits to transmit onto the channel will take how much time? So 1000 divided by 3000 seconds. It is 1 by 3. You can take like 0.33 seconds. Multiplied by 1000 will be 330 milliseconds. Correct? This is called transmission time. The time needed, I will call it as TT. So what is TT? The first time that I am introducing? Transmission time. Time needed to transmit the frame onto the channel. And then it will take some time to reach the packet or the bit from this area to this area. Like this, like a road. It will take some time for you to go from this place to this place. Like that, the time taken by the bit to travel from this point to this point is called TP. This is called propagation time. propagate, time taken for one bit to travel to propagate from one end of the wire to the other end where the other host is present, is called propagation time. And then I will have another time called TX, processing time. So the time needed by the host to process this packet once it comes, this frame, once it comes at the other host receiver, that is called processing time. So every protocol will have these, every channel will have its bandwidth, and then based on that you will have transmission time, propagation time, and processing time. So in the previous protocols we assume that processing time was negligible. So what is processing time is this, transmission time is this, and delay is propagation delay. Sometimes this propagation delay is also called latency. So you have to remember these definitions. All right. So this is the first protocol which has total unrealistic assumptions. Total unrealistic. We have infinite buffer space available at, so it means whatever rate the sender can send, the receiver will be able to accept it. If it sends 10 packets, it will accept 10 packets. It will not say that I can accept only 5. No, infinite space. Infinite amount of data is available for sending it to the receiver. So everything unrealistic. Ideal conditions. Okay. Now next video we'll see the other, by relaxing one of the condition, that we don't have infinite buffer space. So that means the issue of flow control will arise. So how to deal with flow control problem, we will have to see in the next protocol. Okay.